Well, hello everybody and welcome back. Not really a whole lot of time to work on the bench this week. Things are really busy at work. I had an x-ray tube go on a CT and we had a 10-hour day on that one, not including travel, which was another 3 or 4 hours, I don't know. But I did get a little bit of footage of it. I'm collecting some video from different service calls on CTs, and I'm going to try to do another little follow-up video, or a little part 2 video on CT when I get a chance. So that's going to be a little bit of an undertaking though. So what I thought I'd do right now, since I have a few free minutes to myself and don't feel like watching TV, is I thought I'd answer a viewer question today. This is actually several viewers asked this same question, probably in a couple different ways, but same question. And that is, how do you mount the heat sinks, or these TO3 transistors, onto the heat sinks? So what I thought I would do is kind of take you through the process of it and tell you a little bit, at least a little bit that I know about it, how I do this. Now, the first thing, you can see this one here, I just kind of mounted here as an example onto this heatsink, and this one is using the mica pad and the silicone, and it's actually using one of these little sockets. And this is typically how most of the vintage amplifiers are going to look like when you do them. They're going to use this type of mounting with these little sockets. Some of them will actually use little grommets that look kind of like, I don't know, something like this. These little eyelets, and they fit inside here, and they insulate the screw from the chassis. And then, you put them through the back here, and then you use a little nut and screw and a little terminal to get the collector. But most of them are going to have these little sockets. Now, a couple of things that we need to talk about is there's different materials for mounting transistors, but we're only going to talk about two, because really these two are the only important ones that we're going to look at when working with vintage amplifiers. Now, when working with high temperature semiconductor devices in some of like the medical equipment I work on, like a gradient amplifier for an MRI or something like that, some of those transistors can, and MOSFETs and so forth, can get very, very hot, and they use very special thermal pads that are very expensive. We're not going to talk about those. We're only going to talk about these two, because really these are the two you're going to see the most of. So, and there's ceramic ones. There's all kind of different materials, but this first type is the old type that has been around for a very long time, and these are mica. This is just a mica pad. It's similar to glass, kind of. It's a little bit flexible, but it's also brittle. It can crack and snap, so you don't really want to flex them too much. But they're a very good conductor of heat, and they're a very good insulator at the same time. So they've been popular for many years, and they just fit right over the transistor like this. And you're going to use a thermal compound. And that thermal compound is very important, because what it's going to do is, if you look at these transistors, they're very mass produced. And as you can see, they're not very well polished. They're a little bit shiny, but if you got really, really up close on it, you would see that there's little tiny inclusions in there. And anywhere there's an inclusion, you're going to have a little air pocket between this mica pad, which is very smooth, almost like glass, and this metal. So you have to have something to couple and smooth out those inclusions to properly thermally couple this metal to this mica, and then the other side of this mica back to the metal of the heatsink. Now, some heat sinks are highly polished, some of them are less polished, but all of them have, again, very slight inclusions in them. And those are what you're going to want to, or occlusions, whatever you want to call it. I'm not an English major, so go ahead and correct me online, but you're still going to get bad English sometimes. Anyhow, you're going to get those little marks in there, and you're going to have to use the grease to fill it in. So that's really the purpose of thermal compound. Now we're going to talk about this second type later, but we're just going to talk about the old way of doing it. And I still do this quite a bit. There's a lot of advantages to it. Number one, it's very durable. You can really tighten these down very, snug, and use this mica. It's never going to break down. It's never going to wear out. It's never going to burn up. It's really lasts a lifetime. And this silicone heatsink compound, this is very common. This is GC Chemicals, which is a very popular that you can buy online. Just about any of the electronics parts houses will sell this. And this is the original old-fashioned style silicone heatsink compound. And it's just like a white kind of grease that gets all over your fingers and gets all over everything, so I'm not going to mess with it too much. But you can get it that way, and you can also get it in little containers like this. And this kind is a little bit pastier, but they're both the same. They both work. It doesn't matter which kind you use. Now, let's talk a little bit about this heatsink paste for a minute, because when you're using this for vintage audio equipment like this, I recommend, and again, this is just my personal opinion, I recommend the normal basic silicone heatsink paste. Now, when you get into like computer electronics, like microprocessors and video cards and things like that, you'll see some more exotic types of heatsink compound that contains copper, silver, other different compounds. You want to try to avoid those. Anytime you're working with radio equipment or with vintage amplifiers like this, try to avoid those unless you really, really know you have a data sheet that explains completely what is in them and what their properties are. Believe it or not, some of the more exotic heatsink compounds can actually be somewhat either conductive or capacitive. And to get even more into it, you can put a blob of it on this table and touch your meter to it, and it won't read anything. But as soon as you put it onto one of these pads and you put it in, sandwich it in between this transistor and this aluminum, and then you crank down on these screws and you apply pressure, it can become conductive, and it also can have capacitive effects, which can act as like putting a very small picofarad value capacitor between the collector of this transistor and this aluminum heatsink, which may be screwed to the chassis, which is ground. So you might be between the collector and ground putting a very low capacity capacitor in there, or a very high resistance resistor in there. Some heatsink compound is actually conductive. And it's designed to couple devices that don't need to be electrically isolated. Be aware of that. Not all of it is. You hear about that Arctic silver, which is that really expensive stuff that comes in teeny little tubes, and people use it for their high performance microprocessors. You have a 6 or 8 core, an i7 Intel processor. Those get very, very hot, and they have very large heat sinks. Some of them have highly polished copper heat sinks, and they use that silicone or that silver or even copper compound. Some of that is not conductive, but some of it is. And it doesn't matter when used in that instance, because as long as you keep it between the top of the microprocessor body and the bottom of the heat sink, it's not going to touch anything electrically. You don't need any type of electrical insulation or isolation. So just keep that in mind. If you think you're going to improve the performance of your amp by putting this $50 heatsink compound in there, you might actually be putting problems into the amp. And there have been incidences of that happening. So just use this stuff. It works. It has worked for the last 40 or 50 years. And it'll work for the next 50 years. The other thing is, don't worry about if it dries out a little bit. Sometimes this heatsink compound, this stuff not so much, but some of the older stuff will dry out a little bit. But as long as you don't move it or decouple it from this in any way, it will still do its job for the most part. As long as it doesn't get all crusty and shrink, it will still work. So this is a very durable, long-lasting, efficient way to couple a transistor to a heatsink. Okay, and we'll go over how to apply it here. Now, how I apply it is you want to make sure all the surfaces are nice and clean. And you can use some alcohol or just, make sure they're clean. Especially if you're reapplying this. Clean all the old stuff off first. Then you're going to take just a little bit of this, and I just use a little dot. I'll put some on here just to show you, so I'll get it all over my fingers for you. You just take a little bit on the tip like this, and I use a paintbrush, an artist's brush, a flat artist brush like this, and I take a pair of scissors and I trim about half of the bristles off, so the bottom part of the bristles there are pretty stiff. And then I just take and I start in between the pins on a TO3 case like this, and I work my way out. And I just brush this on there, and there's really no neat way to do it. You're going to get some of this on your fingers, but it's just silicone paste. It won't hurt you. Just keep paper towels around. And you brush this on until you're just starting to cover the metal, so you don't really see too much metal below there. Again, you don't want to make this so thick, because believe it or not, if you put too thick of a coating on here, it'll actually be counterproductive. It'll actually take the heat more time to pass through it. It actually almost acts like an insulator. So, nice thin coat, spread it out really well with this. You saw I only used a tiny little dot on the one side of the brush. Then you take your pad, place it on top of here. Then you take the same amount and brush it on this side of the pad. Then you turn it over and couple it to your heatsink and attach your hardware. And that's really all there is to it. It's very simple. Again, I really like this method, which is the oldest, and you'll see me do this quite often on some of the older equipment. I don't always use it, but I know that when I do this, number one, it's going to give me a good coupling to the heatsink, and number two, it's going to last a very long time because it's very durable. Alright, the second type are these little silicone pads, these little silicone pads, and you can see they're very flexible. If I get them close up here and kind of get them at a little bit of an angle, get some light on them, on the subject, I don't know if you can see, but they actually have some texture to them. Just a little bit of texture. And they're not much thicker than the mica. And the neat thing about them is they handle very high heat, higher heat than these transistors will ever get. They're electrically insulating, so they act as an electrical insulator. And you don't have to use any grease with them. You just put them on just as they are, dry. You put your transistor through there, put your mounting screws in, and you're good to go. No fuss, no muss, no mess. Now, why don't I just do this all the time? And is there a big difference? Well, first of all, I would not use this on an older style heatsink where this is not really smooth. This does not fill in the occlusions as well as the grease does. So that's the first thing. So on a transistor that's relatively smooth, a new one like this one was, and a nice heatsink like this that's really smooth, doesn't have to be totally polished, but smooth, these work great. However, on the older style transistors that are real gritty on the bottom, and the heat sinks that have a lot of mill marks on them, they don't work as well. They will not couple as well. But if they have good physical contact with the transistor and with the aluminum, they will do just as good of a job as these. Now, the second reason I don't always use these is, depending on the type of transistor, Some of them are little thin metal like this one. Other ones, if I have an old one here, let me get one of these really old ones out. See a difference? See how thick the metal is on that one? See how thick the metal is on this one? And sometimes, if you look, this has a very sharp corner. This would not be my first choice to use one of these with, because as you tighten the hardware down, so you're going to mount this on here and put these screws in, as you tighten this down, if you tighten this unevenly, what can happen is that sharp corner can actually dig into these. You'll actually see, if you put one of these transistors on here, you'll see the corner of this pad will start to curl up like that, because that corner is actually digging in there, and you do run the risk of cutting through this. This can be cut very easily. It's not very strong. And if this cuts through there, it will short out to the heatsink, and you no longer have electrical isolation. So depending on the transistors and depending on how easy they are to get to check and so forth, you can't over tighten these. When you use these, you have to just snug the screws up, and if you see this curling up on the edges, you're tightening it too hard. Again, if I think that it's a well-machined heatsink, it's easy to get to, I can tighten them evenly, and they don't have these sharp, old-fashioned sharp corners, then I will use these because they're simple, they're not messy, and they last forever. So that's one of the only downsides of these. But other than that, these are great. So both methods will work, okay, as long as you follow those couple of rules. And really, that's all there is to mounting a transistor to a heatsink. So very short video, but I kind of wanted to cover that because I know I've been getting some repeat questions about that. I hope that helps you. And again, I'm sure there's many of you who have a lot of different ideas or opinions or other methods that you use, and feel free to share them in the comments. But that's how I do it, and that's kind of how I've learned it over the years. So there you go. Again, as always, I thank you for watching, and I thank you for following my channel. If you like this or any of the videos, give us a thumbs up. And as always, I wish you all peace, joy, happiness, and good health in your lives. And stay well for now, and until next time, take care. Bye-bye.